So what if you could connect your brain, your actual mind, directly to a computer? I'm not talking about a keyboard or a mouse. I mean connecting at the speed of thought. We're on the verge of a future where human intelligence and AI could literally become one. Let's dig into just how close we are to making that a reality.
And look, this isn't just some sci-fi fantasy anymore. The tech is called a brain-computer interface, or BCI for short, and it really is one of the most exciting and, yeah, maybe one of the most disruptive frontiers in science today. We're talking about a direct pathway between the 86 billion neurons firing in your brain and the entire digital world. And this is the grand vision, right? This is what's driving so much of the hype. You have people like Elon Musk who see BCIs not just as a new kind of tool, but as a fundamental evolution of what it means to be human, a way for us to merge with AI, to keep up. But how on earth do we actually get there? Okay, so to really get the promise and the peril here, we have to ground ourselves in the actual technology. This isn't magic, it's hardcore engineering. And it all boils down to one big question. That single question splits the entire field of BCI development down two completely different roads. And each one has its own incredible upsides and some really serious downsides. So here's the deal. It's all about a massive trade-off between getting a clear signal and, safety. On one side, you've got invasive BCIs. This is the real deal. Surgery, implanting tiny electrodes right into the brain tissue. The signal you get is incredibly clean, super high resolution, but it's brain surgery with all the risks that come with it. Then on the other side, you have non-invasive BCIs. Think of something like an EEG cap that you just wear. It's way safer, much more accessible, but the skull acts like a muffler. It blurs the signal, making it noisy and a lot less precise. So this choice, inside the brain or on the brain, changes everything. And what's possible is being chased in two very different worlds at the exact same time, the military and medicine. And this is a classic dual-use problem, where the very same technology can be used to create a weapon or a cure. Now, what's fascinating here is that this isn't just speculation. This comes straight from a Rand Corporation report written for the US military. They're imagining a soldier who can control an entire swarm of drones with their mind, communicate silently with their team using synthetic telepathy, and make life-or-death decisions in a split second by linking directly with an AI. It's all about creating a seamless fusion of human and machine on the battlefield. And then, you see the flip side of that coin. For basically every military idea, there's an equally profound medical application. The same tech that lets you fly a drone could let someone with paralysis control a robotic arm as if it were their own. The ability to read brain signals could give a voice back to someone who has lost the ability to speak. It's about restoring what disease or injury has taken away. And this isn't some far-off dream. A study funded by DARPA, the military's research agency, found they could boost short-term memory by 35%. They figured out a person's specific brain pattern for creating a memory, and then used an implant to basically replay that signal, reinforcing it. This just goes to show you the real, tangible potential we're talking about.
But with this kind of incredible power comes some pretty unprecedented peril. I mean, when technology can literally read from and write to the human brain, it throws up some massive ethical questions that our current laws are just not ready to handle.
So in response, some really smart people have proposed a whole new set of human rights called neurorights. The idea is to build a firewall around our minds. But as a critical paper from the National Institutes of Health points out, it's not that simple. Each of these proposed rights creates its own thorny new problems.
Okay, take the right to free will. The NIH paper asks a pretty basic question. How do you create a legal right for a concept that philosophers haven't been able to agree on for thousands of years? Neuroscience itself kind of complicates the idea, suggesting our brain makes decisions before we are even aware of them. So trying to write free will into law is tricky, to say the least.
Then you have the right to equal access to enhancement. Now this sounds totally fair, right? But what if it creates this intense social pressure to upgrade your brain just to keep up? The paper argues it could end up punishing people who choose not to get enhanced, making them seem inferior at work or in school. It could turn a personal choice into a social requirement.
And what about a right to personal identity? This one's a real paradox. How can you have a right that says technology can't alter your sense of self, while at the same time you're promoting enhancement technologies that are designed to do exactly that? The two ideas are basically at war with each other.
And finally, the right to mental privacy. The researchers point out a really tricky dilemma here. If we lock down all brain data and make it 100% private, we might actually prevent the data sharing we need to build fair, unbiased AI algorithms for these devices. In other words, total privacy could accidentally lead to more dangerous and biased BCIs.
So the bottom line from these researchers is skepticism. They're basically arguing that instead of trying to invent a whole new legal framework from scratch, maybe we should focus on making sure our existing legal systems, our ideas of privacy, consent, and equality, are ready for the neurotech age.
So while the ethicists and lawyers are debating all these huge questions, a very real, very high-stakes race to build the future is already happening. And this isn't just in university labs, this is a full-blown corporate competition.
All right, let's look at the main players. You've obviously got Neuralink, which is aiming for a consumer device, that human-AI symbiosis, using these flexible polymer threads they think can be upgraded over time. But then you have companies like Paradromics and Synchron, who are laser-focused on medical uses. Paradromics is using super durable materials for a lifetime implant. And Synchron has this wild stent trode that they can insert through your blood vessels, which means no open brain surgery. So you see completely different goals, different philosophies, and very different tech.
But here's where things get really interesting: the data. Just look at the raw difference in performance. Neuralink's device has a reported data speed of around 10 bits per second. Paradromics, on the other hand, is delivering over 200.
I mean, that's not a small difference. That is a 20 times gap. A source at Paradromics put it perfectly. It's like comparing an old dial-up modem to a DSL connection. It is a generational leap in how much information you can move.
So why does that matter? Who cares about the data rate? Well, more data means you can do more complex things. A simple task, like moving a cursor on the screen, might not need a lot of bandwidth. But those life-changing applications we talked about, restoring the full, rich, natural sound of a human voice, that takes an enormous amount of data. That speed could be the difference between something that's just a cool gadget and something that's a genuine miracle. And that kind of brings us back to the heart of it all. We have this incredible technology that can heal us and enhance us, but it could also create new weapons, new inequalities, and that forces us to ask this one final question. When technology gives us the power to rewrite what it means to be human, who gets to hold the pen?